Have you ever wondered why some locomotives from your grandfather's era are still hauling freight while modern engines are heading for the scrapyard? Today we're counting down 10 old locomotive engines that were built to last forever. Some of these are still earning their keep after millions of miles. Number 10. EMD GP9. In 1954, Electromotive Division looked at their successful GP7 and asked a simple question: what if we made it even more reliable? The answer was the GP9, and railroads couldn't buy them fast enough. Electromotive Division built over 4,250 of these workhorses, making it one of the best-selling locomotive models in history. But here's the thing: they didn't just sell well, they refused to die. The secret was the 567C prime mover, an engine so understressed at 1,750 horsepower that mechanics started calling the GP9 a run till it drops diesel. And drop it didn't. These locomotives were designed for branch line work, yard switching, and secondary mainline duties. Nothing glamorous, just endless grinding, day after day, reliability. Canadian National still had GP9RM units in active service as recently as 2022. Think about that. Locomotives built in the 1950s still earning revenue nearly 70 years later. The rebuild programs tell the story. Railroads didn't scrap these engines when they wore out. They rebuilt them again and again. Some GP9s have been through 3 or 4 major overhauls, receiving everything from new 645 power assemblies to completely modernized electrical systems. The GP9 proved something important. You don't need cutting-edge technology to build something that lasts. You need robust engineering, accessible components, and a design philosophy that puts reliability above everything else. Over 30 GP9s are preserved today, and several still operate on heritage railroads, doing exactly what they were built to do, just slower and with more tourists watching. When the Pennsylvania Railroad decided to electrify their northeast corridor in the 1930s, they did not just want a locomotive. They wanted a statement. What they got was the GG1, a 4,620 horsepower electric giant that would define American railroading for nearly 5 decades. The numbers are staggering. 139 units were built. 49 years of continuous service. A design so successful that the last GG1 was not retired until October 1983, nearly half a century after the first one rolled out of the shops. But here is where it gets truly remarkable. These were not pampered museum pieces running occasional excursions. They were frontline passenger locomotives hauling some of the heaviest, fastest trains in North America. The GG1's secret was its articulated design. 2 powered frames connected by a ball joint allowed the massive locomotive to navigate curves that would have derailed a rigid machine of similar size. At 79 feet long and 475,000 pounds, the GG1 was enormous, but it moved through the railroad's infrastructure like it belonged there, because it was designed to. The most famous GG1 story involves Unit 4876, which crashed through the floor of Washington Union Station in 1953. The locomotive fell into the basement, a spectacular disaster that made national news. Here, they cut the GG1 into pieces, hauled it back to Altoona, welded it back together, and returned it to service. That locomotive ran for another 3 decades after being literally reassembled from wreckage. Raymond Loewy's iconic streamlined design made the GG1 beautiful, but Pennsylvania Railroad engineers made it immortal. 16 survive in museums today, silent monuments to an era when railroads built things to last generations. Number 8. The EMD SD40-2. If you've seen a freight train in North America anytime in the last 50 years, you've probably seen an SD40-2. Electromotive Division built 3,957 of these locomotives from 1972 to 1986. And here is the astonishing part. The majority of them are still working. The SD40-2 became known simply as the standard among railroad mechanical departments. The 645E3 prime mover delivered 3,000 horsepower with a reliability that bordered on remarkable. But the real innovation was the -2 electrical system, which used solid-state, modular components that could be swapped in the field. When something failed, and eventually something always fails, you pulled a module and plugged in a new one. No complex troubleshooting, no specialized equipment, just robust, practical engineering. Burlington Northern was the largest buyer, rostering nearly 900 SD42 locomotives at the peak. They loved these locomotives so much they kept rebuilding them rather than buying new power. And they were not alone. Union Pacific's SD40N program rebuilt 486 units. CSX continues their SD43 program. Norfolk Southern maintains active rebuild facilities. These railroads are not sentimental, they are cheap. And the SD42 is still the most cost-effective way to move freight in many applications. Think about that. Locomotives designed in the early 1970s, still being rebuilt and returned to service in 2023. Not preserved, not displayed, working. The SD42 did not just last. It became the benchmark against which all subsequent locomotives are measured. And 50 years later, the benchmark is still hauling trains. Number 7, the Swiss Crocodile C68. The mountain hauler. In 1919, Switzerland faced a problem. The Gotthard line, threading through some of Europe's most demanding mountain terrain, needed electric locomotives powerful enough to haul heavy freight trains up brutal grades. The solution was a machine so distinctive, they named it after an animal, the crocodile. The CE68-2 earned its nickname from its articulated design, with a long hood at each end connected by a central cab section. It looked like nothing else on rails. More importantly, it worked like nothing else on rails. The original 51 production units delivered 2,700 kilowatts of power, later upgraded to nearly 3,620 horsepower. For a locomotive designed over a century ago, those numbers are remarkable. But here is what made the Crocodile truly special. The Swiss Federal Railways ran these locomotives in regular service until 1986. That is 67 years of continuous operation on one of the world's most demanding rail lines. The Gotthard route includes gradients of 2.6% and countless curves. These locomotives did not just survive that environment, they thrived in it. The American Society of Mechanical Engineers designated the Crocodile a historic mechanical engineering landmark in 2022, recognizing both the locomotive's innovative design and its service longevity. SBB Historic maintains Unit 104-253, built in 1920, in operational condition. Over a century old, and it still runs. 7 crocodiles survive today, preserved as monuments to Swiss engineering excellence. They represent something important. The Gotthard was the first major railway line to operate entirely on renewable hydroelectric power. The Crocodile was not just built to last, it was built to demonstrate that electric traction could handle the heaviest work railroading had to offer. The American Locomotive Company knew they were fighting for survival when they designed the RS-3 in 1950. Electromotive Division was eating their lunch in the diesel market. Alco's response was a road switcher that would prove nearly impossible to kill. Between 1950 and 1956, Alco built 1,418 RS-3 units for railroads across North America and beyond. The locomotive delivered 1,600 horsepower from its 244 prime mover, a respectable figure that could handle everything from local freights to branch line passenger service. But the real story is not the specifications. It is what happened after the warranty expired. The Alco 244 engine had a reputation, not entirely fair, but not entirely wrong either. It needed attention. It consumed oil. It required mechanics who understood its particular personality. But railroads discovered something interesting. The rest of the locomotive was essentially bulletproof. The frames were overbuilt, the trucks were robust, the electrical systems were straightforward and repairable. So railroads did something clever. When the 244 engines wore out, they repowered the locomotives with EMD 567 prime movers, or later Alco 251 engines. The RS-3 became a platform, a foundation that could accept different power plants as technology evolved. New York Central's rebuilt units earned the nickname DeWitt Jeeps because they combined Alco bodies with EMD internals. As of 2022, RS-3 locomotives were still in active service on short lines and industrial railroads. 70 years after production began, these machines continue earning revenue. The RS-3 proved that locomotive longevity is not just about the original design. It is about adaptability. Build the foundation right, and the locomotive can evolve with the times. The EMD F7 is the locomotive that killed steam. Between 1949 and 1953, Electromotive built 3,849 of these streamlined cab units, more than all other F units combined. It became the best-selling cab unit in history, and for good reason. The F7 simply worked. The 567B prime mover delivered 1,500 horsepower, with a 20% improvement in continuous tractive effort over the earlier F3. That does not sound revolutionary until you understand what it meant in practice. Railroads could run F7 units harder, longer, and with less maintenance than anything that came before. The economics were devastating for steam locomotive manufacturers. Southern Pacific was the largest buyer, accumulating 530 F7 units. But the locomotive found homes everywhere, from the Santa Fe's famous Warbonnet passenger trains to humble freight drags on Midwestern branch lines. The F7 did not care about prestige. It cared about showing up day after day, ready to work. Many F7 units remained in service through the 1970s, with some lasting into the 1990s on secondary services. That is 40 years of operation from a locomotive design that was considered mature when Eisenhower was president. The bulldog nose became iconic, appearing on everything from model trains to corporate logos. Several F7 units remain operational today on heritage railroads, still pulling passenger excursions with the same effortless competence they displayed when new. The F7 did not just outlast steam. It outlasted the railroad companies that bought it, the corporate structures that ordered it, and the executives who signed the purchase orders. Some machines transcend their era. The F7 defined one. Number 4. Southern Pacific Cab Forward. Most steam locomotives put the cab at the back behind the boiler. Southern Pacific looked at their Sierra Nevada routes, choked with tunnels and snow sheds, and decided conventional thinking was trying to kill their crews. Their solution was radical: put the cab at the front. The cab forward design emerged from necessity. On conventional steam locomotives, exhaust smoke drifts back over the cab. On most routes, that is an annoyance. On Southern Pacific's mountain crossings, it was lethal. Crews were passing out from smoke inhalation in the tunnels. Something had to change. The AC-12 class, the final and most powerful cab forwards, were built with a 488 wheel arrangement and were articulated monsters that burned oil instead of coal. That was critical. Oil could be piped from the tender at the rear to the firebox at the front. No firemen had to shovel coal forward against the direction of travel. The entire locomotive was redesigned around keeping crews alive. Southern Pacific built 256 cab forwards between 1909 and 1944, making it the largest fleet of this configuration anywhere in the world. Wartime records show these locomotives hauling 7,000-ton trains over Donner Pass day after day with reliability that kept supplies flowing to the Pacific. The cab forwards were not a novelty. They were essential infrastructure. The crews loved them. For the first time, engineers could see where they were going without breathing smoke. They could spot obstacles, read signals, and survive their shifts. The cab forward proved that sometimes the right solution means questioning every assumption. Everyone knew steam locomotives had cabs at the back. Southern Pacific proved everyone was wrong. Number 3. Norfolk and Western Class J. The Norfolk and Western Railway didn't just operate steam locomotives, they perfected them. While other railroads rushed to dieselize in the 1940s, Norfolk and Western kept building steam power at their Roanoke shops. The Class J, a 484, was their masterpiece, and only 14 were ever built because 14 were enough. The specifications border on the ridiculous 5,400 horsepower from a streamlined machine with 70-inch drivers, boiler pressure of 300 pounds per square inch, a locomotive capable of 100 miles per hour that could also muscle heavy freight over the Appalachian grades. The Class J wasn't specialized. It was supreme. Norfolk and Western built these locomotives between 1941 and 1950, and they dominated the railroad's passenger service until dieselization finally came in 1959. But here is what makes the Class J remarkable. One of them refused to die. Number 611 was preserved after retirement, then restored to operation in 1982 for Norfolk Southern's steam program. When the steam program ended, number 611 sat again. But the locomotive had captured the public imagination. The Fire Up 611 campaign raised $3.5 million to restore the engine a second time. In 2015, number 611 steamed again, and it continues operating excursions today. Virginia designated it the official state steam locomotive in 2017. The American Society of Mechanical Engineers named the Class J a National Historic Mechanical Engineering Landmark in 1984, recognizing what Norfolk and Western achieved, the finest steam passenger locomotive ever built for American railroads. Only one survives, but that one refuses to stay retired. Some machines are too good to die. Number 2, Union Pacific Big Boy. The name says everything. In 1941, the American Locomotive Company delivered something unprecedented, the largest steam locomotives ever built. 25 big boys, each one 133 feet long and weighing 1.2 million pounds with its tender. These were not just locomotives, they were rolling monuments to American industrial ambition. The Big Boy's 488 four-wheel arrangement was unique. No other railroad operated anything with this configuration. Union Pacific needed locomotives that could haul massive freight trains over the Wasatch Mountains without helper engines. The Big Boy delivered 135,375 pounds of tractive effort, enough to move almost anything the railroad could assemble. Each locomotive cost $265,000 in 1941, and about $5.7 million today. They were designed for speed as well as power, stable at 80 miles per hour despite their enormous mass. The engineering required to make something this large move that fast without shaking itself apart was extraordinary. Union Pacific retired the Big Boys in 1962, but the locomotives had already become legends. 8 survive in museums across the country, and then, in 2019, Union Pacific did something nobody expected. They restored number 4014 to operation. The restoration took 5 years and required rebuilding systems that had not operated in nearly 6 decades. But it worked. Today, Big Boy 4014 is the largest operating steam locomotive in the world, running excursions that draw thousands of spectators. Each of the original Big Boys averaged over 1 million miles in service. Number 4014 is adding to that total, proving that some things are simply too magnificent to stay retired. Number 1, the GE ES44AC. At the top of our list sits a locomotive that might surprise you. It is not vintage. It is not preserved. It is the workhorse currently hauling freight across North America, and it represents the pinnacle of locomotive longevity engineering, the GE ES44AC. General Electric introduced the ES44AC in 2003 with a bold promise. This locomotive would still be earning revenue in 2033 and beyond. They designed it with a 30-year service life as the baseline expectation, not the maximum, the minimum. Everything about the ES44AC was engineered for the long haul. The GE Evo 12 prime mover delivers 4,400 horsepower while meeting Tier 2 emissions standards. But power is almost secondary to durability. The locomotive's alternating current traction motors eliminate the brushes and commutators that wear out in direct current systems. The adhesion control can detect wheel slip in milliseconds and adjust power delivery before damage occurs. Every system is monitored, every component is accessible, every failure mode has been anticipated. Union Pacific, BNSF, CSX, and Norfolk Southern have all made the ES44AC a cornerstone of their motive power strategies. These railroads do not buy locomotives on sentiment, they buy them on life cycle cost analysis. And the numbers say the ES44AC will still be competitive decades from now. The ES44AC represents everything the railroad industry has learned about building locomotives that last. The lessons from the SD40-2 modularity, the GG1 structural integrity, and the GP9 maintainability all feed into modern locomotive design. The ES44AC is designed to be rebuilt, upgraded, and modernized throughout its service life, evolving with technology rather than becoming obsolete. 50 years from now, locomotive historians will probably talk about the ES44AC the way we talk about the SD42 today, as the machine that defined an era and refused to leave when that era ended. The tradition of building locomotives to last forever is not history. It is still happening, one revenue mile at a time. And there you have it. 10 locomotives built to last forever, and most of them did. Which one surprised you most? Let me know in the comments, hit that like button, and subscribe for more. Thanks for watching.